Hi everyone, my name is Elder Brian Angelo S. Ledesma from BECE 3B, and this is my presentation on ECE 23 Performance Task Number 6. So, in this presentation, we will talk about convolutional code. So, what is convolutional code? Convolutional code is a type of error correcting code that generates parity symbols via the sliding application of a Boolean polynomial function to a data stream. So, convolutional code was introduced in 1955 by Peter Elias. So, in the statement, what do we mean by parity? So, parity is a check bit that added to a block of data for error detection purposes. So, it is used to validate the integrity of data and the value of it assigned either 0 or 1. That makes the number of ones in the message block either even or odd depending upon the type of parity. So here is an example of convolution color diagram that rated as 1 over 3. So why it is 1 over 3? So in every one input there are 3 output, which it shows here in the diagram. The N1, N2, N3. So we can locate its output by locating this arrow. So we can use this as our reference to locate its value of its output, which is the N1 is equals to input XOR MO or M0 XOR M1. By the way, this symbols represents as an XOR gate or an exclusive OR gate, which has the characteristics if where the output is 1 if the total number of input that are 1 is odd, which means if the input A is 0 and the input B is 0, the output is 0. If the output A is 0 and if the input is 0 and the input B is 1, the output is 1. Reverse, it is like one answer. And if the input A is 1 and the input B is 1, the output is 0. That is the characteristics of XOR gate. So for the N2, the M0 XOR M1. For the N3 output, we can determine it by input XOR M1. So in this, we will determine the following, which is the transition table, state machine diagram, and Trellis diagram. So first, we must know its function. So the function of transition table, state machine diagram, and Trellis diagram. So for transition table, is basically a tabular representation of the transition function. So for the state machine diagram, it depicts the various states that an object may be in the transition between those states. So for the Trellis diagram, is a way to show the transition between various states as the time evolves. So it is obtained by specifying all states on the vertical axis and repeating this vertical axis to the time axis. So here's the transition table of the convolutional color diagram rated as 1 over 3. So we will use this as our preference or our way to determine its output. So transition table has its input and the current state, output, and the next state. So in transition table, it chooses four variety of possible bits, which is 0, 0, 0, 1, 1, 0, and 1, 1. So for the input, it has two possibilities of input, which is 0 and 1. So if the input is 0, the current state is 0 and the M1 is 0 results to N1. N1 as 0 output. So we'll use this. If the input is 0, XOR M0 is 0, XOR M1 is 0, the N1 is 0. So for the N2, if the MO or M0 is 0 and XOR M1 is 0, the output M2 is 0. For the N3, the N3 is input is 0, XOR M1 is 0, the output of N3 is 0. For the next state, M0 and M1 is 0. So this block represent as the, for the next state, represent as the shift register or shift right, which means if the value of the input is 0 and the value of M0 is 0 and the value of M1 is 0, the value of input is transferred to M0 and the value of M0 is transferred to M1, which results that M0 is 0 and M1 is 0. So next, if the input is 1 and the MO is 0 and the M1 is 0, the N1 is 0, which is if the input is 1 XOR MO is 0, XOR M1 is 0, the output is 1. So for the N2, M0 is 0, XOR M1 is 0, the output is 0. And for the N3, N3 is input is 1, XOR M1 is 0. So the input or the output of N3 is 1. So the next state is the M0, M1 as M0 has an 1 and M1 has an 0. So the value of input, which is 1, is transferred to M0, and the value of M0 is, which is 0, is transferred to M1. So the next state is 1 and 0. Next, if the input is 0 and the MO is 0 and the M1 is 1, the output of N1 is 1. So input is 0 and XOR MO is 0 and XOR M1 is 1, the output of N1 is 1, which is shows here. So for the N2, M0 is 0 and XOR M1 is 1 and the output is 1. For the N3, input is 0, XOR M1 is 1, so the output is 1. And the next state is 0, 0, or shift register the value, transfer the value of input to M0 and transfer the value of M0 to M1, which results for 0, 0. So the same procedure on this remaining section on the transition table. For the state machine diagram, it shows the repetition of every possible output of the current state and the next state. So it shows that in state diagram, if the current state is 0, 0 and the next state is 0, 0, the arrow shows its rotation, which is the same. Current state is 0, 0 and next state is 0, 0, so it's the same, with an output of 0, 0, 0, 0 and 0 with an input of 0. So next is if the input is 1, the current state is 0, 0. Now it transferred to next state to 1 and 0, which is shown in this arrow. So transfer to 1 and 0 with an input of 1 and an output of 1, 0, 1, which is input of 1 and the output of 1, 0, 1. So next, if the input is 0 and the current state is 0, and for the for this 1 and 0, it goes to 0 and 1, and 0 and 1, the next state is 0 0, which goes to 0 0 with an input of 0 and an output of 1 1 and 0. Next, if the input is 1 and the current state is 0 1, which it shows there 0 1, and it goes to the next state is 1 and 0. So 1 and 0 goes to 1 and 0 with an input of 1 and output of 0 1 and 0. Same with this 1 1 current state, which is 1 1 current state goes to the next state, which is 1 1 also, go back to 1 1 and has an output of 1 0 0 1 0 0. So next is the Trellis diagram. So Trellis diagram is just copy the four bits, which is the combination of bits, which is 0 0 1 0 1 and 1 0 and 1 1. So you just copy here the section. So unlike the state machine diagram, the Trellis diagram shows only its output when it's the same binary bit, which is 0 0 and this is 0 0. So if the current state is 0 0 and the next state is 0 0, which is in the arrow, which goes to the left, not goes to the right, the input is 0 and the output is 0 0 0. And for this, which it shows here, same with the state machine diagram, if the current state is 0 0 and goes to 1 0, which it shows here with the same reference, so the input is 1 and the output is 1 0 1. So for the 0 and 1, it goes to 0 0, which is shows here on the state machine diagram also. 0 0 with an 1 input with our output of 1 1 and 1. So for the 0 1, it goes to 1 and 0, which shows also here with an input of 1 and output of 0 1 and 0. Same with 1 and 0. So 1 and 0 goes to 0 1, which is here, goes to 0 1, 1 and 0 goes to 0 1 with an input of 0 and an output of 1 1 and 0. So here again, 1 and 0 goes to 1 1, which it shows here, 1 1 with an input of 1 and output and an output of 0 1 and 1. So same with 1 1. 1 1 goes to 1 and 0, which shows 1 and 0 with an input of 0 and output of 0 0 1. But it's the same here. So lastly, 1 1 goes to 1 1 with repeat itself, because the current state is 1 1 and it goes to the next state is 1 1. So in the state machine, it shows the rotation of it for the 1 1, but in the Trellis diagram, it shows the specific rotation, or not the rotation, or it's it's possible rotation. For 1 1 goes to 1 1 also for the current state, and for the next state, and a result of 1 input with an output of 1 0 0. So that's the end of my presentation. Thank you.